Alright, so we have this question on sets. Okay, they're saying assume arbitrarily countable sets of elements to verify the following set laws. Okay, so the first one there, we have A union, and then in the brackets we have B intersection C, and then on the other side we have A union B, and then intersection A union C. So this law here is called the distributive law. Okay, this is distributive law, and then this one here is one of the De Morgan's laws. Okay, so how are we going to prove this? Okay, we are going to assume countable sets of elements. So let's say set A. Okay, you just choose any set as long as it's countable. Let me say set A has 1, 2, and then 3. Okay, and then let my set B be equals to, let in my set B let me have 3. Okay, and then set C. Okay, let's set C have 1, 2, and then 4. Okay, this is our set C, and then let's say our universal set. Okay, let our universal set have 1, 2, 3, and then 4. Okay, so we have the universal set, set A, set B, set C. Okay, so this set here you can choose any sets that you want. So let us prove that A union B intersection C is the same as A union B intersection A union C. Alright, so let's start with the A there. So the A, we've been given that it's what? 1, 2, 3. Okay, let's find B intersection C. Okay, so B intersection C, when I look at this set B and this set C here, we see that there's nothing common. So that will be an empty set. Alright, so now we are finding the union of A union the B intersection C. So we see that this A set, okay, is just 1, 2, 3, and then this B intersection C is an empty set. Okay, so what's the union of A with an empty set? We're just going to get the same set, which is what? A. So 1, 2, 3. So this here will be what I have on my left hand side here. So I should have written here that this is my left hand side. So what about the right hand side? Okay, so the right hand side we have A union B, and then intersection A union C. Okay, so let's find our A union B. So A union B, we are combining elements of this and this. Okay, so we see that it's just going to be 1, 2, and then 3. Then we're going to say intersection. Let's find A union C. So this is our A and this is our C. So if we find the union there, to just be 1, 2, 3, and then 4. Okay, and then now we can get the intersection of these two sets. Okay, so the intersection of these two sets will be what? 1, 2, 3. So we're going to say the intersection is just 1, 2, 3. Okay, so what can we see? We see that what we had on the left hand side here is actually the same as what we have on the right hand side. Okay, so we can say since left hand side is equals to right hand side, okay, hence verified. Okay, so we verified the first one. Let us verify the second one, which has De Morgan's laws there. Okay, so I will erase, let me not erase the universal set. Okay, I will erase this part and this part down here. Okay, so now let's prove the second one. Okay, so the second one we have A. Okay, let me choose another color. So on the second one we have A union B, and then we have a complement is equals to A complement intersection what? B complement. So let's find A union B, and then we can find its complement. So we see that A union B will just be equal to we combine elements in A and in B, so that will be 1, 2, 3. Okay, so this will be our A union B. What about our A union B complement. So we know that complement means all the elements that are not in this set. Okay, so when we look at our universal set here, we see that the only element that is not in A union B complement is 4. So I'm going to put a 4 here. Okay, so it means our A union B complement, which is our left hand side, okay, is just 4 there. Now let us find what we have on the right hand side. So right hand side, we have A complement intersection B complement. So what is the A complement? Okay, so this is my set A here. So my A complement will contain all the elements that are not in A but they are in the universal set. So we see that it will just be 4 there. So this will be 4, and then I say intersection. Okay, let's find B complement. So B has 3 only, so it means in its complement we are going to write all the members that are not in this B but they are in the universal set, so meaning 1, 2 and 4. Okay, and then we take the intersection of these two sets, we see clearly that the 4 will be common there, so it means 4 will be there like that. Okay, so this will be our A complement intersection what B complement. So from this we see that our left side, which is A union B complement, is actually equals to, okay, A complement intersection B complement, like that. Okay, so we can say hence verified. Okay, so we verified these two laws here. So that's how we can go about this question. Okay, so please like, subscribe to my channel for more videos, and then those who need extra lessons, okay, you can register with us, just 150 per course per month.